So you're probably not surprised that an arithmetico-geometrico series can extend to infinity. So over here, we're asked to sum 1 over 6 plus 2 over 6 squared plus 3 over 6 cubed plus 4 over 6 to the power of 4, and it just continues forever. Now let's refresh our memories a little bit. So why exactly is this sum right over here an arithmetico-geometrico series? Well, that's because this series contains both an arithmetic component and a geometric component. So if you're confused on what I'm talking about, let's do it together. Let's identify the arithmetic component first. So in this series, the arithmetic component would just be the numerators. Because you can see the numerator goes 1 plus 2 plus 3 plus 4. So this is an arithmetic series with common difference of 1. Now let's identify the geometric series component. The geometric component would be the denominators, because it goes 1 over 6 plus 1 over 6 squared plus 1 over 6 cubed plus 1 over 6 to the power of 4. And we see that the arithmetico-geometrico series is the result of taking each term in the arithmetic series and pairing it up with a term in the geometric series. So the first term would be 1 times 1 over 6, which is 1 over 6. The second term is 2 times 1 over 6 squared. The third term is 3 times 1 over 6 cubed. The fourth term is 4 times 1 over 6 to the power of 4, and it just continues. Now we're going to approach an infinite arithmetico-geometrico series in the same way that we did for a finite arithmetico-geometrico series. So we're going to call this whole series S. So S is what we're trying to find. Now let's bring in a new series. What will this new series be? Well, this new series is going to be our initial series multiplied by the common ratio of the geometric series component. The common ratio of the geometric component is 1 over 6. So the new series that we're going to introduce is going to be S times 1 over 6. Which is 1 over 6 squared plus 2 over 6 cubed plus 3 over 6 to the fourth Now it's time to take the difference between these two series. S minus s over 6 becomes 5s over 6. Equals 1 over 6. plus 1 over 6 squared plus 1 over 6 cubed plus 1 over 6 to the fourth and guess what? We know how to work out this part. This is just an infinite geometric series with first term 1 over 6 and common ratio 1 over 6. So all of this over here works out to be the first term, which is 1 over 6, over 1 minus the common ratio, which is 1 over 6 as well. And this turns out to be 1 over 5. So we know that 5s over 6 should be equal to 1 over 5. So we can multiply both sides by 6 over 5 to get s on its own. And we find that s ends up being 6 over 25. So this is just another example of us using the exact same method to tackle a new problem that we haven't seen before. But now that we know how to evaluate infinite Arithmetico-Geometrico series, honestly, how much harder can this really get?